Hello friends, I welcome you all to watch my new video on class 12 physics, and in this topic we are going to find out force on electric dipole in external electric field. Okay, so as you can see in the figure, this is a dipole which has been kept in uniform electric field lines. Okay, so this is uniform electric field lines in which electric field lines are equidistant and have the same magnitude everywhere. Okay, and so we will find out that what is the torque acting on this dipole due to this electric field. So this is what we have to see in this lecture. So as you can see that q net, okay, total charge, as you already know, this is positive q and this is negative q. So total electric charge will be 0, and as you can see that force is acting in this direction due to positive charge. force is acting on this direction, and due to negative charge this is in this direction. Okay, so both the forces are equal in magnitude, but they are in opposite direction. So total net force acting on this dipole will be 0. Okay, and as you already know that electric dipole moment is nothing but q, any charge, and distance between them. So between the dipole, between this dipole, total distance between the two charges is 2a. Okay, now as you already see, this is electric field is uniform and net force acting on 0. So as now we will find out that this is the perfect condition where torque will be acting on this due to this charge. Due to center of dipole, okay, a force will be acting like this, that this force will try to move this dipole in this direction, whereas this negative charge will try to bring in this direction. Okay, so a torque will be acting on this. As you have already studied in class 11 that if net force is 0, then a torque will be acting on this dipole, and the center will be the center of dipole. Okay, now so if you have to find out that torque, that what is the torque acting on, we have represented torque with this tau. So what will be the torque? So this will be one second. Force multiply by distance, c, the perpendicular distance, okay, between these charges. So this is q, this q, and this is q, and this is angle this is making with electric field lines is theta. So what will be, this will be the cos component, and this will be the sine component, and this will be the hypotenuse. So what will be this x? We have to find out x, because we have to find out the perpendicular distance. As what is the definition of torque? Force multiplied by the perpendicular distance between the two charges. Okay, so perpendicular distance between two charges is x. Okay, and so what will be the x? X will be nothing but this distance is 2a. Okay, and this is sine theta. So what will be the x? X equal to if you will write sine theta, this theta, what will happen? X upon 2a, this distance. Okay, so what will be x? 2a sine theta. Okay, now this x, force multiplied by x, and force is nothing but QE multiplied by 2a sine theta. Okay, and if you will try to write q into 2a e sine theta, okay, then this is nothing but your, what is this? This is B, this is P, your electric dipole moment. Here you can see. Okay, so this is, you can write this as P and E sine theta, which you can write P, okay, cross E, electric dipole moment cross product with E, okay, electric field intensity gives you the torque. Okay, now there will be some special cases, and what will be the special cases we will see. Special cases. Okay, what are the special cases? Torque, you already know that P E sine theta. Okay, now imagine a case where this is this, just imagine a situation, this is your electric field, okay, for this, and your dipole is like this, Q, okay, and this is plus Q. So this will, as we have already discussed, that this force will try to rotate this dipole in this direction, and this will this negative charge will, this force will try to move this dipole in this direction. Okay, so this will try to come like this. Okay, so now you can see what is the electric field. Electric field is already in this direction. Okay, and what is the electric field, electric dipole moment? Dipole moment, you can see that negative to positive, so also this will be also in same direction. So PE, angle is theta. If angle is theta, if theta equal to 0 degree, then torque is 0. Okay, now just imagine a scene that second case. Okay, so 1 second, just imagine a second case. Now if this was for this direction, and if the electric field is in this direction, okay, and this is your center of dipole, and just assume a scene that where minus Q and this is plus Q. Okay, just this is in opposite direction. And one more thing I forgot to add, that if torque is 0, then this is equilibrium state. This is called equilibrium state, or state stable equilibrium, you can say. Okay, now if we are assuming that and now I am erasing all this, so please take a screenshot of that, and now I am erasing this. Now if we have to calculate case number 2, case 2, when torque is nothing but torque you already know is nothing but P cross PE sine theta. Okay, now if theta is 180 degree, this is the case when negative charge is in this direction. Okay, if you have rotate and theta is 180 degree means negative charge in this direction and positive charge this direction. Then what will be the direction of electric dipole moment? This will be in this direction from negative. As you already know that electric dipole moment direction is nothing but from negative charge to positive charge. Okay, and electric field line is in this direction, so they are making 180 degree with each other. Okay, this is your electric field line. Electric field line is in this direction, and whereas electric dipole moment direction is this opposite direction. Okay, so if theta is 180 degree, what will happen? Again, sine 180. What is the value of sine 180? 0. So your torque reduces to 0 when theta is 180 degree. And this case we call this state is unstable equilibrium. Okay, this is unstable equilibrium. So there might be objective question asked on this, that if your torque, okay, in your torque, if theta is 0, what will be the torque, and if theta is 180 degree, what will be the case? So you have to simply say that this is torque will be 0 when theta is 0, and when theta is 180 degree also it will be, torque will be 0, but it will be unstable state, and this is called a stable equilibrium. What you say this is a stable equilibrium. Okay, so this is the thing. Now we already know that force on an electric dipole in external electric field. Okay, and if net force is 0 and net charge is 0, then there will be torque acting, and that will be acting across center of dipole. So this force will try to move this dipole in this direction, and this force will try to rotate this dipole in upper direction. So this is the two case, and it's very important topic. Now we will learn Gauss law. Okay, and it's very important, so we will derive the equation for Gauss law in next video. Till then, bye bye. Please do like and subscribe, and I request you that if you have any questions, please do post in comment section. I will try to make a video on them which will help you out. Thank you, and happy learning.